This isn't just a cool picture, it shows one of the biggest problems Spotify ever had. It's the story of something tiny, a rumor of a shark biting a cable revealed the huge hidden flaw in Spotify infrastructure. And this is blurry original photo that went viral. A shark, a cable, and the global panic. At the time it seems crazy. Could a physical event in the ocean crush one of the world's largest, most popular streaming apps? The answer is unfortunately yes. Major crash system forced them to completely rebuild their entire infrastructure technical foundation. So, how did a cut cable cause a worldwide music outage? To understand that, we have to start from the beginning, P2P era. When Spotify first launched, they did something brilliant. Instead of spending billions on giant server centers, they used peer-to-peer network. Look at this diagram. In the early days, 91.2% of their music were delivered from P2P, not from their own servers. You were actually streaming music directly from other users' computers. For that, they even bought BitTorrent client uTorrent to get uTorrent main developer on board. So, why to use P2P? First, it saved them fortune. If they had to serve every stream themselves, it would cost a lot of money. By letting users share music they load, they avoided massive infrastructure cost. Second, it's much faster to get popular song from a user in your city rather than from a server across the globe. This P2P system dramatically reduced lag and kept music flowing instantly. It was a genius way to grow quickly, but all that genius was held together by single, fragile thread, and that what Shark incident exposed. The core problem wasn't the streaming, it was database. At this time, Spotify main user session and crucial operations data was stored in single Postgres master node located in Europe. When the cable connecting to the US from the US to the Europe was cut, whether by Shark or just a bad luck, it was like cutting main power line to their entire. Every time a user in US tried to log in, start a session or change the setting, that request had to cross across the globe. The single connection point became overwhelmed when they had millions of users and the database couldn't handle the traffic. Result, system-wide failure. This incident triggered one of the biggest changes in Spotify history, migrating away from their core monolithic database. They moved from their fragile, centralized Postgres to a distributed NoSQL solution, Apache Cassandra. So, what is Cassandra? Cassandra is fundamentally different. It's a NoSQL distributed database. Imagine a Postgres database was a single massive vault. If that vault is locked, the whole bank shuts down. Cassandra, however, is a network of smaller, identical safes, the nodes all talking to each other in a ring. There is no master node, you can add or remove node easily, and if one of the nodes goes down, the others simply pick it up. This is why it's built for horizontal scaling and fault tolerance. Of course, Cassandra has its own cons, like eventual consistency, but it's always about trade-offs. The database wasn't the only issue that needs to be broken down. The entire application was a massive monolith, one giant tangled code base. An issue in the payment code, for example, could bring down entire recommendation engine. The fix? Microservices. They broke down monolithic into small independent services, streaming, payment, authentication service, and so on. Now, if one of service like payment service fails, the streaming service continues to work, preserving core user experience. This allows for independent developer, faster updates, and massively increased resilience. To support this technical change, they also needed organizational change. Spotify became famous for its squads and tribes models. A squad is like a small startup team focused on one feature, for example, radio feature. They autonomous contain all the skills needed to deliver that feature end to end. Multiple squads form a tribe. This structure literally designed to reflect microservices architecture, ensuring small teams can work quickly on independent components without stepping on each other's toes. And this is nervous system of Spotify, the event pipeline. Every action you take, a play, skip, search, or even lowering the volume is an event, and Spotify processes billions of these events every day, originally using their own self-managed Apache Kafka cluster. As we already heard before, Apache also created Cassandra, and also Apache is an open source foundational organization that created a lot of cool software products. One of them is Apache Kafka cluster. At one point, they were logging 60 billion events per day. But operating Kafka at that massive scale was an ongoing battle. They faced three core issues: no reliable persistent storage, producer instability, and general operational complexity with tools like MirrorMaker. The solution was another massive migration, lifting and shifting their data infrastructure to Google Cloud. They replaced self-managed Kafka with PubSub and Dataflow. PubSub is fully managed infinity scalable messaging queue. This system is a new central nervous system of Spotify. It takes billions of events, processes them instantly with Dataflow. The feeds result in data to Cassandra, which updates your taste profile. This sophisticated event pipeline is the engine behind all the personalization. It's the technical reason why Spotify can launch features like Meet Your DJ. The DJ isn't a magic, it's a machine learning model that just consumed most accurate real-time data about your listening habits, data flowed through new Google Cloud pipeline. Finally, let's put it all together and ask simplest question: how does the song play? It's a two-stages process. First, when you press play, your client takes API gateway, which routes requests to playlist service or recommendation service. This service fetches song metadata, title, artist, length from the relational database in the backend. This is very small and very fast query. Next, you're requesting your music through CDN, which backups by audio storage. Your request is immediately routed to physically closed CDN service. That server has audio file for that song and it fetches quickly from audio storage, which is just cloud storage like Google Cloud Storage, and streams it to you in small chunks. This minimizes the distance the audio data travels, ensuring no buffering or lags with high audio quality. The Spotify is using two CDN providers, Fastly and Akamai. As you see in this diagram, Fastly has POPs in every continent, and Akamai also has a lot of CDN POPs across the globe. This is final comprehensive diagram entire Spotify architecture. On the top right, the event delivery system feeding data to Cassandra for your test profile. On the bottom is the streaming flow. The API gateway handles the metadata request to relational DB, and the client handles the audio request directly to the global CDN. The lesson is clear. The shark incident forced Spotify to trade off between monolithic simplicity to a distributed specialized complexity. They evolved from a vulnerable P2P system to resilient cloud-native powerhouse that can handle 500 million users without skipping a beat. If you want to know more about Spotify, I recommend you to watch a series called The Playlist on Netflix. This is a cool series which shows all the history from the perspective of different people who worked and founded Spotify.